Hello, one component system. A system which consists of different phases of the same chemical species at equilibrium is called a one component system. Some examples of one component system are water system, carbon dioxide system, sulfur system, etc. For example, water, solid, liquid, vapor. This equilibrium can be split as water solid into water liquid, liquid into vapor, solid into vapor. Water system, vaporization curve, OA, OB, sublimation curve, OA dash, metastable curve, OC, melting curve. Curves univariant system, curve OA, the vapor pressure curve. It represents the equilibrium between liquid water and vapor at different temperature. From this phase rule, F equal to C minus P plus 2, component only water 1, phase 2 plus 2, 1. The curve has 1 degree freedom to describe the system at any time. It is necessary to state either temperature or pressure. If we fix the temperature, the pressure will be fixed automatically, so the system is univariant. The upper end of the curve OA is marked by the critical point A, where the liquid and vapor phase merge together and result into homogeneous phase. The critical temperature of water is plus 374 degrees Celsius at 218.5 atmospheric pressure. Curve OB. The sublimation curve. This curve represents the equilibrium between ice and vapor. The system is univariant. Along this curve, for each temperature, there is only one pressure at which water vapor is in the equilibrium with solid ice. Similarly, for each pressure, there is only one temperature at which both the phases coexist. The lower end of the curve extends to absolute zero minus 273 degrees Celsius temperature. Curve OC fusion curve. This curve represents the equilibrium between ice and water. It is called the fusion curve of ice or the melting point curve. F equals C minus P plus 2, 1 component, 2 phase, plus 2, 1, the 1 degree of freedom. This curve shows the effect of pressure on melting point of ice. The curve is slightly inclined towards the pressure axis. It indicates that the melting point of ice decreases with increase in pressure. This is because the density increases as the volume of the ice decreases on melting, which is exceptional from other substances. That's why the curve shows a negative slope. From the Clapeyron equation, dP over dt equal to delta S over delta Tv. When ice melts into water, delta dP over dt equal to delta fusion, delta S fusion over delta Tv fusion. Delta S fusion, enthalpy change for fusion, T temperature, delta B fusion, change of volume for fusion, and delta S fusion increases with increase in temperature, but volume decreases. Delta S fusion equal to Bf minus Vi less than 0. So the slope dP over dt becomes negative. Curve OA, the metastable equilibrium. The curve represents the liquid water and water vapor at metastable equilibrium. It is sometimes possible to cool water below its freezing point without turning into solid ice. It is called the supercool water. It's a very unstable condition in presence of ice or any other solid, or by stirring it instantly converts into solid ice. The point O, the three curves OA, OB, and OC meet a point O. This point is known as triple point. At this point, the three-phase solid, liquid, and vapor of the water system remain in the equilibrium with each other. From the phase rule, F equal to 1 minus 3 plus 2 equal to 0. Sorry. The point O, F equal to C minus P plus 2, component 1, the phase solid, liquid, and vapor, three phase. So 3 equal to 0, degree of freedom 0. This means that point has no degree of freedom. The system is invariant. The point has a definite temperature and pressure, which is 0.0098 degrees Celsius at 4.58 millimeter pressure. Neither the temperature nor the pressure can be varied. Any change in temperature or pressure will destroy the equilibrium among the three phases. Areas bivariant system. Single phase ice, water, vapor are capable of stable existence. In the phase diagram of water, AOC represents the liquid phase, AOB represents the vapor phase, BOC represents the solid phase. To define the system completely at any point in these areas, both the temperature and pressure are necessary. From the phase rule, F equal to C minus P plus 2, one component, one phase. So F equal to 2. Thus, phase areas have 2 degrees of freedom. Okay, it's all about one component system phase diagram. Thanks for watching, and request you all like, comment, share, and subscribe. Thank you for patience. That is now. Bye bye. See you again.